Hello and welcome to this tutorial about the binomial coefficient. Suppose we want to know in how many different orders we can arrange the letters A, B and C. This can be done easily by hand, so we have A, B, C, A, C, B, B, C, A, B, A, C, C, A, B and finally C, B, A. There you go. At the end we have these 6 possible ways to arrange the letters A, B and C. If we would like to calculate the number of orders, we could say that for the first letter there are 3 options to choose from, namely A, B and C. After selecting the first letter, only 2 letters remain, and thus there are 2 options for selecting the second letter. So if we choose A as the first letter, we have B and C left. After doing this, 1 letter remains, which is automatically the third letter. This information gives us the following calculation: 3 times 2 times 1, because first there were 3 options, then 2, and at the end there was only 1 letter to choose from. The equation 3 times 2 times 1 is also known as 3 factorial, which is 3 exclamation mark. 3 times 2 times 1 gives 6, which is exactly the number of orders we have found by writing out all the combinations. I hope you understand what the factorial function is. Please determine yourself in how many unique orders the letters A, B, C and D can be placed. So far, we discussed 2 examples about the factorial function. It is important to notice that we only use this function if all letters are unique. For the binomial distribution, we have to deal with success and failure, and therefore the binomial coefficient is very important. Suppose we want to calculate the number of unique orders of 2 successes and 1 failure. We cannot just take the factorial of 3, and I will show you why. For a second, let's mark S as S1 and S2. Now we could write down 6 different orders just as we did before. So we have S1, S2, F, S1, F, S2, S2, S1, F, S2, F, S1, F, S1, S2, F, S2 and S1. There you go. If we remove the numbers 1 and 2, the 2 S's are similar. Now you can see that each of the different orders are doubly noted. So these 2 are S, S, F, where these 2 are S, F, S, and finally we have F, S, S. This is because you can rearrange the letters to make a new order, but not every rearrangement produces a different order. So if we change the S with the other S, the order is still similar. There are only 3 unique orders to order 2 successes and 1 failure. We can calculate this number of unique orders by using the binomial coefficient, which is mainly written as n above k. N is the total number of letters, so the S and F together, where k is the number of successes. In our example, this would be 3 above 2 because we have 3 letters but only 2 successes. We could say that the number of unique orders is similar to the total number of arrangements of all the letters divided by the number of arrangements per letter. If we write this down, we get n factorial divided by k factorial times n minus k factorial, which in our case gives 3 factorial divided by 2 factorial times 3 minus 2 factorial. There you go. If we write this out, we get 3 times 2 times 1, because what we saw earlier is that the 3 factorial is similar to 3 times 2 times 1. So 3 times 2 times 1 divided by the factorial function of 2, which is 2 times 1. 3 minus 2 is also 1, so we take another factorial of 1, which is times 1. And we can simplify this. So now we have 3 divided by 1, which is equal to 3, and similar to what we found earlier. I will give you another similar example. Let's calculate how many unique orders we can make from the letters S, S, F, F. Now we have an N of 4 and a K of 2, which gives 4 above 2. The total number of arrangements of all the letters is equal to 4 factorial, where the number of arrangements per letter is equal to 2 factorial times 4 minus 2 factorial. And this 2 factorial relates to the 2 s's we have, but we do this times another 2 factorial, 4 minus 2 is also 2, because we also have 2 failures. So we can write this out by taking 4 times 3 times 2 times 1 divided by 2 times 1 times 4 minus 2 is another 2, so times 2 times 1, which we can simplify. So we have 4 times 3 divided by 2 times 1, which is equal to 12 divided by 2 is 6. So there are 6 unique orders in which we can arrange the letters S, S, F, F. I hope that this video gave you a better understanding of the binomial coefficient. Before you close this video, please try to calculate yourself how many unique orders we can make from the letters success, 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 failure, failure, failure. If you are able to calculate this, I'm sure you understand the binomial coefficient well. I hope you found the right answer on the last question. If not, keep practicing on the binomial coefficient and I'm sure you will do well. Thank you for watching.